Okay, so this is the last page of the 2.6, 2.7 notes, and we're going to be graphing a couple of functions here. This is the one that's on the left, and this, notice, is the same function that we had in a previous video, f of x, where we found the vertical asymptote, the limit as x approaches -2 from the left and from the right, and same thing with -3 from the left and from the right. So we're going to use that previous information on this graph so in order to just kind of, well, we've already done it once, so why do it again? Okay, so we're going to graph this function. First thing we're going to do, we're going to look at this, break it up, factor the numerator. It's a difference of squares, and our denominator is already factored for us. We're going to be putting together all the different pieces. We're going to find our vertical asymptotes, our horizontal asymptotes, and then we're going to find our x-intercepts and our y-intercepts and try to graph this by hand. Okay, so we determined that we had vertical asymptotes of x equals -2 and x equals -3. So right now I'm going to draw a dotted line through -2 and -3. And these are really close together, but hopefully needs to follow. Okay, so we already, back here, let's see, a couple pages ago, we determined that, here's the same function, f of x here, and we determined as x approaches -2 from the left, it approached -infinity. -2 from the right, it approached positive infinity. And then for the other asymptote of -3, from the left, it approaches positive infinity, and from the right, approaches negative infinity. So, using that information, oops, I know that the graph is going to be going like that. It approached from the left of -3 is approaching positive infinity, and the same thing from the right of the asymptote of -2. And then as it approached -3 from the right and -2 from the left, it went down. And so we know that these ends are both going down like that. All right, so let's look at our horizontal asymptote. Horizontal asymptote is, we're going to look at the degree of the numerator, and when you FOIL x times x, or x minus 1 times x plus 1, you're going to end up with the degree, it would be x squared minus 1, which we have here. The degree is going to be 2. And same thing in the denominator. When you FOIL this, you get x times x, which is going to be x squared, and then plus 3x plus 2x is plus 5x plus 6. So our degree is going to be that x times x. The degree is 2. So the degrees match. So according to our rules for horizontal asymptotes, we're going to find the quotient of lead coefficients. Now if I multiply this out, I'd get x squared minus 1 on the top. I get x squared plus 5x plus 6 in the denominator. Our lead coefficients are 1 and 1. So my horizontal asymptote is y equals 1, because 1 over 1 is 1. And so we have this horizontal asymptote at 1. So y equals 1 looks something like that. Sorry, it's a little crooked here. Okay, so now we need to find our x and our y intercepts. To find your x-intercepts, what you want to do is you're going to find your x-intercepts, you're going to let y equal 0. Because if you think of it, if you're crossing the x-axis, anywhere you cross the x-axis, the y-coordinate is always 0. So let's figure out when y is 0, which is f of x, what is x? And I'm going to use this factored form. When does this fraction equal 0? And an important thing to note is that if a fraction equals 0, it's going to be where the numerator equals 0, because when the denominator is 0, it's undefined. So we want to figure out when x plus 1, this is my numerator, and x minus 1, what values of x would make the numerator equal 0? And it would be x equals -1 or x equals +1. So these are my x-intercepts. When x is -1, y is 0. And when x is +1, y is 0. And then now we need to look at our y-intercepts. And the reverse, we're going to let x equal 0 to find my y-intercepts. So if I put 0 in for these x's, what do I get? So we're finding f of 0. Draw a line down here. F of 0 is equal to, we have 0 squared minus 1, and then I have 0 plus 2 and 0 plus 3. Evaluating that, the numerator is -1. 0 plus 2 is 2. 0 plus 3 is 3. 2 times 3 is 6. So I have a y-intercept of -1, 6. So a little point right about there. 6 of the way down to 1. Now putting all of this together, I'm going to get a graph that looks something like this. It's approaching infinity here, and then I know that this is my horizontal asymptote, so it's going to be approaching that line, y equals 1, there. And then remember I had, these are both approaching -infinity, and it doesn't ever intersect the x-axis because I found all my x-intercepts. So it's going to be down here somewhere, in between those two asymptotes, so not touching them, but it's a real narrow, like almost like a parabola, but not a parabola because parabolas go out forever. And then on this side, I'm going to need to do a little erasing for that piece, I think. But I know it's approaching positive infinity, but then it also has to cross through here and that y, so the x-intercept, the y-intercept, and then this x-intercept. And then I know it needs to go towards that horizontal asymptote. So my graph should look something like what I have here. So I graphed this, and you can see it's kind of hard to tell where the y-intercept is with this graph, but the rest of it does appear to look like what we want. So I'm going to change my window a little bit because I only went out to x equals 2, and it was hard to see that the graph was approaching 1. Y equals 1, the horizontal asymptote. So I'm going to go out a little farther in that direction. And what it does when I made my window bigger, these pixels, it doesn't allow the graph to graph them very well. But let me go out even farther because it is hard to tell that this is actually approaching 1 as we go out in the x direction. I'm going to go even farther because it should look like it's approaching 1. Actually, it probably is. It's just that my y, if I trace along here and go out, yeah, when x is 22, it's 0.8. When I go out to x equals, let's go to 30, it's even 0.85. Let's go to 50. It's 0.9. It's approaching 1. So that matches what we thought it should look like. Okay, the next example, the one on the right, I want you guys to try to do the same thing. And again, recall that we already found our asymptotes and our behavior near the asymptotes back here previously in the notes. You can do it again if you think you need the practice. But we determined, after factoring, we determined that we had a removable discontinuity, which I haven't talked about yet. I'll do this with you now. Okay, it's not letting me go down here, but we figured out that we had a removable discontinuity at x equals -1. Sorry, my computer keeps jumping up. At x equals -1, and then a vertical asymptote at +2. And as you approach 2 from the left, it was approaching -infinity, and 2 from the right, it goes to +infinity. So let's go back to this graph. All right, and so I'm going to, we have g of x equals, again, I can factor the numerator, and the denominator has a removable discontinuity at x equals -1. And I would like you to note that. show you what that means. We had a vertical asymptote at x equals 2. Our degree, now we can use this simplified version to figure out our other asymptote. We have a degree in the top of 1, degree in the bottom of 1, so our lead coefficient is going to give us our horizontal asymptote, and it'll be y equals 1, because our quotient of lead coefficients is 1. All right, you guys go ahead, pause the video and find the x-intercepts and the y-intercepts, and then try to graph this, and then come back. So I have a x-intercept of positive 1, and to find my x-intercepts, you are going to let y equal 0 and then solve for x. And so we can use the simplified version of g of x after we remove the common factor of x plus 1 in the numerator and denominator. And so we have a fraction x minus 1 over x minus 2. And a fraction, recall, is 0 when the numerator is 0. So at x equals 1, we have a x-intercept 1, 0. So that's that point right there. To find your y-intercepts, you're going to let x equal 0, and you should have gotten y is 1/2 when x is 0. So I have this point, which is right about here. I've drawn my vertical and horizontal asymptotes. And then previously we found that as x approaches 2 from the left, 2 with a little minus sign, it was going towards negative infinity. And as we go towards 2 from the right, it was going towards positive infinity. And there's no other intercepts because we found all our intercepts. So this is what the graph is going to look like, something like this, going through these 2 points and approaching the horizontal asymptotes as we go out towards positive and negative infinity. And then if you look, this is what the graph looks like. Notice that right here we have a missing pixel at -1, and that is what a removable discontinuity looks like. It's one point that doesn't exist on the graph versus an asymptote which splits the graph and makes one side go to infinity, and in this case one side goes to negative infinity and one side goes to positive infinity. That's not always the case. They can go both towards positive infinity or both towards negative infinity. But yeah, we have that little missing point, and that's called a removable discontinuity, and that happens when you can remove the factor in the numerator with 1 in the denominator. And to get this windowed so that that removable discontinuity shows up, I needed to go to zoom, and then if you choose zoom decimal number 4, you get that graph, because it's just graphing at decimal, it moves over like by 0.1, so it shows that point right there, versus if you're in a standard window then it won't show up. So that's our notes from 2.6 and 2.7. So now what I'd like you to do is try to do the 2.6, 2.7 practice and bring your questions to me when you have them.